morning. Today we are beginning the very first lesson for the semester. This is semester 2. Welcome back. We're covering geometry lesson 7.2. Now the reason it says 7.2 even though it's the first video is because 7.1 is the Delta Math assignment that I gave you. So this is on using ratios to determine proportion. And so what are you going to be able to do? You're going to be able to use ratios to find the scaled value of, or the scaled size of a geometric figure and verify whether or not those have the same proportion. Okay? All right. And this video is going to support the rate and proportion worksheet that I have assigned to you separately in Clever. And you must put, as you know, you must take notes. And on those notes, I want you to very neatly print your first and last name, the date, period, and the lesson notes name and number. And then you're going to upload it to me using the Student View Dropbox by 11:59 p.m. Saturday, or you may email me if you wish. But if you email me, then make sure that you also include your first and last name, date, period, and lesson notes name and number in the email header. Okay? All right. So the first thing I want you to do today is we're going to have you assume that A equals 2. So that's the variable A, if you will. And B equals 1 for the below 2 problems. So what I've written here is what is A divided by B? Okay, so A divided by B, we just substitute. So substitute. And in this case, you're going to substitute 2 for A and 1 for B. So you're going to have A is 2 and B is 1. So 2 over 1. So that equals 2 over 1. I'll take away the question mark. You now have a little problem with a solution. Okay? So that is called a ratio. It's also shown as this, 2, 2, 1. So that's basically ratio notation, if you will. So ratio notation. So that shows you how you would be converting this. Now here it says what is B over A. So again, you're going to substitute, right? So we're going to do the same substitution over here. And so B over A is going to equal, B is 1 and A is 2. So the ratio notation would be 1 over, or 1 to 2. So 1 over 2 here is the ratio in fractional form. 1 to 2 is what this says in ratio notation. Now, they're A is A and B is B, and you've got a 2 and a 1 in each one of these ratios, but they will mean very different things. So if you've got something where the ratio is 2 to 1, let's just say A is A square, and so let's say A here is a square, and its sides are 2 and 2, and B is a square, and its sides are 1 and 1. So 2 to 1 tells you that A is 2 times bigger, 2 times bigger than B. Okay? So A is 2 times bigger than B. All right, and so over here, 1 to 2, squares are reversed. So here's B, 1 and 1. Here's A, 2 and 2. So now if in this case b is smaller, well, here we said a is 2 times bigger than 1. 2 over 1, 2 over 1. Okay, get the idea. But this is 1 over 2. Well, what is 1 over 2 as a fraction? It's 1/2. So, what we're really saying here is that b is 1/2 times. Now, x is for times. Why don't I say times? Why don't I write times? That might be easier for you. Times bigger. Or I should say smaller. 1/2 times smaller. Because it's smaller. Than a. Okay? So, and I'll change this x to 2 times. So 2 times. All right? Move this over a minute. All right. So 2 over 1 is 2. So a is 2 times bigger than b. 1 over 2 is 1/2. So b is 1/2 times smaller than a. That's the principle that's behind ratios. You're basically comparing different lengths. And so we're going to be looking at geometric figures where we've got different lengths, and their shape is the same, excepting that the lengths, the corresponding lengths, are some fraction or multiple of each other. And that's what's going on here. Okay? All right. So let's talk about computing ratios. I put this blurb out here because it's definitional and helps you. So if A and B are two quantities that are measured in the same units, now that's important, and trying to see if I've got something here I can circle this way that you can see well. The same units, then the ratio of A to B is A over B. Okay. Now, why the same units? Well, we'll see in a moment. Again, you have to have, it's like comparing apples to apples and oranges to oranges. You gotta have the same units, okay? All right, so the ratio of A to B can also be written as, and then A dot dot B, which is what I showed you before. And because a ratio is a quotient, meaning it's a division problem, its denominator cannot be 0. So that's an important thing. No zeros. No 0 in the denominator. Little important side rule. Okay? And ratios are usually expressed in simplified form. So, for instance, the ratio of 6 to 8 is usually simplified to, as 3 to 4. So, you know, if you look at that, fractionally, 6 over 8 can be reduced by dividing by 2, right? So divide, let's put it over here, 6 over 8, so divide by 2, and you get 3 over 4, which is what we show over here, okay? So we're going to simplify these two ratios. Now, please note that this is 12 centimeters divided by 4 meters. Centimeters and meters are two different types of units. They're related, but they aren't the same. This is 6 feet over here in B divided by 18 inches. And of course, you're familiar with feet and inches, and you know, again, they are not the same. So what you're going to want to do is you're going to want to simplify the unlike units. So let's write this out here. let's see. Simplify ratios with unlike units. Right? So that you can divide them, right? And then simplify the resulting fraction if possible. So then simplify the resulting fraction. If possible. Sometimes there you don't need simplification. Okay? All right, so this in the case of the first one, 12 centimeters and 4 meters. Well, meters are 100. Each meter is 100 meters. So if I were to take this and I would write it as 12 centimeters divided by, and then I'm going to put 4 times, I'll use red, times 100 meters. I'm sorry, centimeters. Centimeters. Because each meter is a centimeter. And if we wanted to be, really color-coded on this, we could say, okay, that used to be the meter, but now it's 100 centimeters, so that's the red, that's the change. Okay, so having done that, then that's going to equal, we can drop the centimeters because they're going to be the same, 12 divided by, and this is 4 times 100, or 400. Now the question is, can we reduce that? Well, we could divide 12 by, divided by 4, can we? And we could divide 400 by 4. So we'll do that. And so 12 divided by 4 is 3. 400 divided by 4 is 100. So this would be our answer. Okay? All right. Now we're going to do the same kind of thing over here. I may have to bring this down just a little bit because I kind of got a little, took a little bit of its space. So this is 6 feet divided by 18 inches. So we're going to do the same kind of thing. We want to get the units to be like units. So in this case, feet, there's 12 inches to a feet. So this is going to be 6 times 12 inches. In this case, we'll just leave it in red, 12 inches. All right? And then that's going to be divided by 18 inches. All right, so 6 times 12, if you multiply that out, you could use a calculator, but it's 72 divided by 18. Now, let's bring this down because we have more room down here. 72 divided by 18. Can we simplify this? Let's see here. Both of these are even numbers. They end in even numbers, so that means we can divide a 2 out of each of these. If I've divided 2 out of 18, because that's the easier one to do that with, I got a 9. If I divided 2 out of 72, I got 36. 9 is an odd number, but you can divide 9 by 3. Can you divide 36 by 3? Well, isn't 9 times 4? Let me see. I think 36. So let's see if we can divide. Let's just get our calculator. Let's clear all this. All right. Now that I've cleared all that, so 72 divided by 18. There's several ways we could do this. I could just take 72 with my calculator, show you a little something interesting. I could take 72 and I could just divide it by 18. Okay, you're using that. You get a decimal normally, but it says 4. Oh, wow. Well, that's easy then. You know it's 4. So 72 divided by 18 simplifies to 4 over 1. So your answer is 4 over 1. Now, why did we leave it this way? Well, remember, this is a ratio. Ratios 4 to 1 are always, they're always characterized by having both their numerator and their denominator showing, okay? Because that's the essence of a ratio. You're comparing apples to apples, more apples to less apples in this case. This is 4 times larger than 1, okay? All right, so that's just simple exercise in simplifying ratios mathematically. Now what we're going to do is we're going to look at it geometrically. So we're going to find the length and width of a rectangle, and here's the rectangle, ABCD, using their ratio. Okay, so you'll notice that the length is identified, AB is the length. Now it just so happens that DC up here will also have the same length. So you could give them both the value of L, because L is a variable basically representing length. And then BC here is width, and so AD has to be width as well. But that's not so important at this point, because we're going to use the formula for perimeter to work this. Why? Because it says the perimeter of rectangle ABCD is 60 centimeters. So they tell you that, perimeter. And so there's a reason for that. We have to figure out what it is. The ratio of AB to BC, so AB, that's this, to BC, so this to this, length to width, is 3 to 2. All right, so they tell you that. They tell you that. They give you that information. So, so let's see. AB, this first one, is the length. So the length is, let's see here. Yeah, the length is 3 and the width is going to be 2. That's going to be the ratio. But first of all, we have to show that we're using perimeter. We want to find the length and width of the rectangle itself. So even though I know that this is 3 times, or this is a ratio of 3 and the other one's a ratio of 2, we have to do some substitution to figure all this out. So we start out with the formula for perimeter of a rectangle. So we got to create that. What is it? So if you dredge this out of your memory from middle school days, that is going to be 2 times the length plus 2 times the width equals the perimeter. Okay? So that's the first step here. That's the formula. Why 2 times the length? Because we have AB as a length here and DC as a length there. There are 2 lengths and there are 2 widths. Okay? Here it is, BC and AD. Okay? Now that we've got that, what we're going to do is substitute for L, and we're going to substitute for W, and we're going to substitute for the perimeter. Okay? So substitute for L, W, and P. So what I'm going to do is, I've got 2 times, now L, what did we say L was? Get my red pen here. So we said it's 3, basically 3 times. Now we don't know what it is, so we'll call this, it's an unknown, so we'll call it 3x. So this is 2 times 3x, x being an unknown variable because we don't really know the length. We just know that there's a ratio between the two lengths and widths. So plus, let's use blue, 2 times the width is 2x. Okay. And then P here. What is P? Well, they tell you this up here. It's 60 centimeters. So that equals 60. So this was the length. This was the width. This was the perimeter. The 2 here was part of the perimeter formula, as was this 2 here. The length was 3 times some unknown, or 3x. Don't confuse that with 3 times. That's 3x. That's the variable x. Okay? And this is 2 times x. All right? So now that we've done that, we can go ahead and multiply together the 2 to the 3 and the 2 to the 2. So multiply or distribute, if you will. And so we've got, let's see, how did I get ahead of myself here? Oh, I got my numbers wrong. Haha. 1, 2, this is 3. Okay, 1, 2, and now 3 over here will distribute. So 2 times 3, distributing, 2 times 2. 2 times 3 is 6, so we have 6x. Plus 2 times 2 is 4x, and that equals 60. All right? So now we're going to combine like terms. Let's move this up so you can see it. Like terms. So we know we have 4x's and 6x's here, so we can add those together. They're now 10x's equals 60. And then we're going to finally undo. So we're going to undo to isolate x. Which means we're going to divide by 10 on both sides. Okay. So divide by 10, divide by 10, and we get 10 divided by 10, of course, is 1. We're left with 1x equals, and then 60 divided by 10 is, well, you can use your calculator, but you can also drop the zeros. It's really 6. And so since it's 6, all right, since x is 6, we now know what x is. But what we want to do is find the length and width. So the length, again, is 6x. So since length equals 6x, all right, length equals 6 times oops, I did that wrong. Since length equals, yeah, length does equal 6x. Okay. 6 times 6 and let's see here. I think they made a little boo-boo, but anyway, that's all right. They meaning the people I took this. And so L is equals 36 centimeters. And since W equals 4x, right? W equals 4 times 6. So W equals 24 centimeters. Now, you got to remember that's the total length and width. So that's divided by 2. So equals 18 centimeters. Divided by 2 equals equals 12 centimeters. So finishing this off, why did I divide by 2? It's because there's 2 lengths and 2 widths, right? So we've got a length here that is 18. This is 18. This is 12. This is 12. Now if we take 18 plus 18 plus 12 plus 12, that should equal 60 centimeters. Let's take our calculator and double check that. So 18 plus 18 plus 12 plus 12 is 60 centimeters. So it checks. This is our check. Okay. All right. So that is how you're finding the length and width of a unit where you don't have all the information. In this case, the unit is a rectangle. So you're finding the length and width of this rectangle. The formula, of course, applies to a rectangle, but this gives you an example of problem solving where you're using ratios to actually come up with the measurement for the lengths and the widths of the rectangle, given the fact that you were only given the perimeter and a ratio of what the lengths and the widths should be. Okay? All right. So then let's then look at proportions. And this is the last part of it, and there's only one more example after it. So you also can have an equation that makes 2 ratios equal to each other. So that means then an equation that equates, meaning they're equal to each other, two ratios is a proportion. Okay? So whenever you see an equation that uses proportions, one on each side, you know you've got, ratios, one on each side, you know you've got a proportion. So the ratio AB is equal to the ratio of CD. If that's the case, then the following proportion can be written. AB equals CD. Now, here's something that you should get to know. The numbers A and D, these are, if you think about cross multiplication, okay, think about going cross multiplying. Numbers A and D are called the extremes. So that's just something to remember. Memorize that. That's the extremes. And the B and the C are the means. Okay? And I always remember the means. It just depends on how you want to do it, but means are what you want to get to in the first part of the equation. So that's the numerator for the C plus the denominator for the B. So if you draw yourself something like this and label it means and extremes, and just make sure you've got these correctly set up, then you're going to be okay. So why do they use that term? Well, it's because of what's called the cross product property, which was what I was talking about. Remember cross multiplication? So the cross product property is the product of the extremes equals the product of the means. So in other words, A times D here, A times D, will equal B times C. Okay? And the reciprocal property, if 2 ratios are equal, then their reciprocals are also equal. So A over B equals C over D, then B over A equals D over C. Okay? So you think about those. Now again, why reciprocal? Well, think about cross multiplication. I mean, all you're doing, A and D are still across from each other, right? Here's A and D here. Here's A and D here. You're still going to multiply those together, and they're still going to equal B and C, which are over here. Okay? So that's one of the wonderful things you might want to get to know as you work with this. And so now we're going to use what we learned to solve the following proportional equations. So the first one is 4 over x equals 5 over 7. We're solving the proportions. In other words, we're going to solve for the variable. So this is x. All right, so cross multiplication, guys. We're told to do that. So I'm going to multiply 4 times 7, and that's got to equal 5x. You did this in middle school. So 4 times 7 equals 5 times x. 7 4s are 28, which equals 5x. Divide by 5, divide by 5, and let's see if we've got, just get my note here. So you got 28 over 5, okay? And that's all you really need to do to this. Can you simplify it any further? Well, you can certainly cancel out the 5s, but you're left with 28 over 5 equals x. Okay, so there's your answer. All right. So now we've got the other one over here, which is, let's write this out more fully. 3 over y plus 2 equals y. All right. So that's the original equation. Now we're going to do the cross product. So cross product property. So think of this as statement reason, if you will. So that means I've got 3 times y equals 2 times y plus 2. And I have to put it in parentheses because the 2 is multiplied to all of the y plus 2. So you're going to have to distribute there. Okay? So now you're going to use the distributive property. So 3y equals 2 times y and 2 times 2. So 2y and 2 times 2 is 4. All right. And then we want to get the y's together, so subtract 2y from both sides, which is again, the subtraction properties. So I subtract 2y, and I get 3y minus 2y is just y, and this cancels, and so y equals 4. And there is my answer. Okay? Now, you can check this by substituting the y, 4 for the y in the original proportion. So let's do that. So check 3, so let y equal 4. So we got 3 times 4 plus 2 equals 2 divided by 4. So 4 plus 2 is 6, so I have 3 over 6 equals 2 over 4. Well, 3 over 6, let's just take this up here. 3 over 6 can simplify to 1/2, right? And 2 over 4 simplifies to 1/2. So it checks. Okay? Oops, it looks like I'm frozen up. Nevertheless, I think you've got the rest of it. So I'm going to let it go from there, and we're going to go ahead and stop this, and I'll let you use it. You should be able to do the rest of it from my oral presentation. Have a wonderful day, and thank you very much.